Chapter 29, Section 1, Interactive Reader, pages 457 through 462, worth 20 points. The Sun, structure of the Sun. Key ideas. As you read this section, keep these questions in mind. How do the Sun's radiative and convective zones compare? What are the three layers of the Sun's atmosphere? How does the Sun convert matter to energy in its core? Page 457. What are the four main layers of the Sun? Where is the temperature probably higher? At the bottom of the convective zone or at the top? What are the Sun's layers? Scientists cannot see inside the Sun. They use models to figure out what the Sun's interior is like. They also study the Sun's surface to learn more about the inside of the Sun. The Sun has four main layers. Highlight the 4 points below: the core, the radiative zone, the convective zone, the atmosphere. What are the four main layers of the Sun? Answer: core, radiative zone, convective zone, atmosphere. Again, core, radiative zone, convective zone, atmosphere. The core. Highlight the core is the Sun's center. Like the rest of the Sun, highlight the core is made up of ionized gas. Because the Sun's mass is so large, highlight the gas in the core is under a great deal of pressure. In fact, highlight the pressure is so great that the core is as dense as iron. The radiative zone. The energy produced in the core moves through two other zones until it reaches the Sun's atmosphere. Highlight, in the radiative zone, energy moves in the form of electromagnetic waves or radiation. The convective zone. The next layer is the convective zone. Highlight, in the convective zone, energy moves by convection. Continue highlighting. Convection is the transfer of energy by moving matter. In the convective zone, highlight, hot gases transfer energy to the Sun's surface. As the gases, highlight, approach the surface, they become cooler and denser. The cooler and denser gases, highlight, sink back to the bottom of the convective zone, and the cycle begins again. Where is the temperature probably higher? At the bottom of the convective zone or at the top? Your answer is bottom. Bottom. Page 458. What is the hottest layer of the Sun? What are the three layers of the Sun's atmosphere? What are sunspots? Left-hand side of the diagram, layers of the Sun's atmosphere. Corona, greater than 1 million degrees Celsius. Chromosphere, 6,000 to 50,000 degrees Celsius. Photosphere, 6,000 degrees Celsius. Right-hand side of the diagram, layers of the Sun's interior. Convective zone, 2 million degrees Celsius. Radiative zone, 2 million to 7 million degrees Celsius. Core, 15 million degrees Celsius. Under the diagram, Sunspot, 3,800 degrees Celsius. Reactions in the sun's core produce energy. This energy moves toward the outer parts of the sun through radiation and convection. Question 3, what is the hottest layer of the sun? Answer, core. What are the layers of the sun's atmosphere? Although the sun itself is made up of gases, scientists consider the uppermost gases as the atmosphere. Highlight, the sun's atmosphere surrounds the convective zone. Highlight, the sun's atmosphere has 3 layers: the photosphere, the chromosphere, and the corona. Question 4, what are the 3 layers of the sun's atmosphere? Photosphere, chromosphere, corona. Again, photosphere, chromosphere, corona. The photosphere. Highlight, the photosphere is the layer closest to the convective zone. Continue highlighting. It is made up of gases that have risen from the convective zone. Continue highlighting. The photosphere gives off most of its energy in the form of visible light. The visible light we see from Earth comes from the photosphere. Highlight, the other layers of the sun's atmosphere are transparent. Thus, scientists sometimes refer to the photosphere as the highlight sun's surface. Next to the picture. Highlight, the dark spots in the figure are called sunspots. Continue highlighting. Sunspots are cooler regions in the sun's photosphere. What are sunspots? Dark spots that are cooler regions. Again, dark spots that are cooler regions. Page 459. Why is the corona visible during a total solar eclipse? What causes electrons to separate from nuclei inside the sun? The chromosphere. Highlight, the chromosphere is the thin layer above the photosphere. Highlight, it is made up of gases that glow with a reddish light. Continue highlighting. These gases move outward from the photosphere. The corona. Highlight, the corona is the outermost layer of the sun's atmosphere. The corona is not very dense, but its highlight magnetic field can stop most subatomic particles from escaping into space. However, some particles do escape into space. Some of these particles are electrons, and others are electrically charged particles called ions. Highlight, the charged particles from the corona make up the solar wind which flows from the sun. We cannot usually see the chromosphere or the corona from Earth. Highlight, however, during a solar eclipse, these layers become visible. Next to the picture, normally we cannot see the sun's corona. During a solar eclipse, however, highlight, the moon blocks the photosphere and the corona becomes visible. Question 6, why is the corona visible during a total solar eclipse? Answer, the moon blocks the photosphere. The moon blocks the photosphere. Where does the sun's energy come from? Highlight. The sun produces energy through a process called nuclear fusion. Continue highlighting. During nuclear fusion, the nuclei of small atoms fuse or combine to form larger nuclei. Nuclear fusion releases huge amounts of energy. On Earth, atoms are made of a nucleus surrounded by electrons. The nucleus and electrons stay together. However, highlight, the high temperature and pressure in the sun's core cause the electrons to separate from the nucleus. Continue highlighting, the nuclei in the sun tend to push away from each other. Continue highlighting, however, the high temperature and pressure force the nuclei close enough to fuse together. The most common form of nuclear fusion in the sun is the fusion of, highlight, hydrogen into helium. This kind of nuclear fusion has, highlight, three main steps. Question 7, what causes electrons to separate from nuclei inside the sun? Answer, high temperature and pressure. High temperature and pressure. Page 460. What happens when two protons fuse? Altogether, how many protons have to fuse together to form one helium nucleus? He is helium. Explain your answer. How nuclear fusion happens. In the first step of nuclear fusion, highlight, two hydrogen nuclei collide and fuse to form a larger nucleus. Each hydrogen nucleus contains only one proton, which has a positive charge. Highlight, when two nuclei fuse, one of the protons emits a particle called a positron. Continue highlighting. When the proton emits a positron, the proton changes into a neutron. Continue highlighting. Therefore, at the end of step 1, the nucleus has one proton and one neutron. Question 8, what happens when two protons fuse? Answer, one proton emits a positron. One proton emits a positron and changes to a neutron. And changes to a neutron. One proton emits a positron and changes to a neutron. Highlight. During the second step of nuclear fusion, another proton fuses with the new nucleus. The nucleus now contains, highlight, two protons and one neutron. Continue highlighting. It is a nucleus of the element helium. During the final step of nuclear fusion, highlight, two nuclei from step 2 fuse together. Continue highlighting. As this fusion happens, two protons are released. Continue highlighting. The remaining two protons and two neutrons are fused together. The protons and neutrons form a new nucleus of a different form of the element helium. Altogether, how many protons have to fuse together to form one helium nucleus? Explain your answer. Looking at the diagram, there are 4 protons in step 1 that fuse together to form one proton and one neutron. So you have 2 of those. As they move into step 2, they fuse with another proton giving us a total at that point of 6 protons that form together. So your answer for number 9 is 6. 4 of them in step 1. 1 more added in step 2 to each new nucleus. Again, your answer is 6. 4 of them in step 1. 1 more added in step 2 to each new nucleus. The sun's energy. One of the final products of this type of nuclear fusion is a helium nucleus. The helium nucleus is about 0.7% less mass than the hydrogen nuclei that formed it. Highlight: the loss of mass has been converted into energy during the fusion process. Continue highlighting: this energy causes the sun to shine and to have a high temperature. Page 461. In words, state the relationship between matter and energy that Einstein's equation describes. Why are there more lines in the sun spectrum than in the hydrogen spectrum? How can matter change into energy? In 1905, Albert Einstein suggested that a small amount of matter can become a large amount of energy. This suggestion was part of Einstein's theory of relativity. Highlight: his theory of relativity includes the equation E equals mc squared. Scientists can use this equation to calculate how much energy a certain amount of matter can become. In this equation, highlight: E represents energy. Continue highlighting: M represents mass. Continue highlighting: C represents the speed of light, about 300,000 kilometers per second. You can see that C squared is a very large number. Therefore, even a tiny amount of mass can become a very large amount of energy. Scientists have used Einstein's equation to explain how the sun produces so much energy. Highlight: each second, the sun uses nuclear fusion to change about 4 million tons of mass into energy. In words, state the relationship between matter and energy that Einstein's equation describes. Answer: a tiny amount of matter can be, a tiny amount of matter can be converted into a large amount of energy. Converted into a large amount of energy. Again, a tiny amount of matter can be converted into a large amount of energy. What is the sun made of? Highlight: scientists use a spectrograph to break up a star's light into a spectrum of colors. Continue highlighting: they can use this spectrum to figure out what elements the star is made of. Dark lines in the spectrum form when elements in the star's outer layers absorb certain wavelengths of light. Highlight: each element produces a unique pattern because of the wavelengths it absorbs. Astronomers use this information to infer which elements are part of the star. In this way, scientists have discovered that, highlight, about 75% of the sun's mass is hydrogen. Continue highlighting. About 24% of the sun's mass is helium. However, the sun spectrum shows that, highlight, the sun contains small amounts of almost all chemical elements. Under the diagram, highlight, the first spectrum shows which wavelengths of light are absorbed by hydrogen. Continue highlighting. The second spectrum shows which wavelengths of light are absorbed by the sun. Why are there more lines in the sun spectrum than in the hydrogen spectrum? The answer, the sun has small amounts of almost all elements. Page 462. Why does nuclear fusion happen only in the sun's core? Will the amount of hydrogen in the sun increase or decrease over the next million years? Explain your answer. What is the main difference between the radiative zone and the convective zone? Complete the table below to describe the sun's atmosphere. Question 1, answer can be found on page 457. The core is the only place where the temperature and pressure are high enough to cause fusion. Again, the core is the only place where the temperature and pressure are high enough to cause fusion. Question 2, answer can be found on page 460. Answer is decrease, because the hydrogen is being converted to helium. Again, decrease, because the hydrogen is being converted to helium. Question 3, answer can be found on page 457. The radiative zone, energy is moving as electromagnetic radiation. Again, radiative zone, energy is moving as electromagnetic radiation. The convective zone, energy moves by moving matter. Again, the radiative zone, energy is moving as electromagnetic radiation. The convective zone, energy moves by moving matter. Question 4, answer can be found on page 458 and 459. Row 1, the layer, first box, is the photosphere. Average temperature is given, 6,000 degrees. Other characteristics, closest to the convective zone, gives off energy as visible light, It's the surface. Second row. First box is given, chromosphere. Second box, 6,000 to 50,000 degrees Celsius. 6,000 to 50,000 degrees Celsius. Third box is given. Glows with a reddish color above the photosphere, generally visible only during solar eclipses. The last row, first box, corona, corona. Second box, 1 million degrees Celsius. 1 million degrees Celsius. Third box, other characteristics. Outer layer, magnetic field that keeps particles in, magnetic field that keeps particles in, solar wind, solar wind. Again, outer layer, magnetic field that keeps particles in, solar wind.